In this lesson, we're going to talk about all types of matrix. We're going to talk about a column matrix, the diagonal matrix, the square matrix, and all types of matrix. So let's get started. Well, the first one says that the column matrix. The matrix to be a column or to be a column matrix, it means that it has one column. So if the matrix has one column, we call this a column matrix. So as you guys can see over here, this is a one column. So this is called a column matrix because it has only one column. So if it is a type of matrix that's just 3, 7, -1, -2, so this is also the same. So this is also a column matrix. So it must be one column to be a column matrix. There must be one column. Okay, so the second one will be a row matrix. When we count a row matrix is a type of matrix that has only one row. So this is row. So this is the structure of row matrix. So as you guys can see, the column matrix, you write it down. So when you write down, this is the structure. That's what it looks like. But when you see this row matrix, you just write to the left. So it will be like 3, 7, 8, 9. So this is a structure. So this is also called a row matrix. So the difference is the row matrix, the structure is different than the column matrix, because as you guys can see, these two are not the same. They are different. Their structure is different. So the difference between this column and row is only their structure. So that's it. And this is the difference between the column and row matrix. So now let's see some other type of matrix. Now, this one is called the square matrix. So the square matrix is a type of matrix that's written in this type of form. So in order for a matrix to be square, it must be 3 by 3 matrix, or it must be 2 by 2 matrix, or 4 by 4. So it must be this type of structure, 5 by 5, 5 by 5, 6 by 6. So this is the type of matrix that is called a square. So it means that it has the same number of rows and number of columns. Because as you guys can see over here, there's 2 rows and there's 2 columns. So that's the reason that we call this 2 by 2. So this is called a square. So when you count this one, there's also 3 rows and there's also 3 columns. So this one is also 3 by 3 matrix. But when you count the like 2, 5, 1, and 2, 2, 1, but look at this one. This one has 2 rows, but it has three columns. So this one is called 2 by 3 matrix. So it cannot be a square matrix. And the reason for that is the number of rows and the number of columns does not match. So now let's get to the zero matrix. The zero matrix are not a square matrix, but the thing with the zero matrix are they are all our zeros. If they're all our zeros, we call it a zero matrix. So this one is the easiest. So that's the thing with the zero matrix. They are not a square matrix. So as you got, we can also say this. This is actually it has 2 rows and it has 3 columns. So this one is 2 by 3 matrix. So that's the reason that I say this one is not a. That's the reason that I say zero matrix and not a square matrix. So now let's go to some other type of matrix. Okay, and then the first one will be the diagonal matrix. And the diagonal matrix are the type of matrix that has a number in their diagonal part. So when you see this type of matrix, there is a diagonal. There is a number in their diagonal. So that's the reason that we call it a diagonal matrix. In addition to that, there must be, or it must be all the time, it must be a square matrix to be a diagonal. To be a diagonal, it must be a square matrix. So, and there's also a number in the diagonal, and whole other part must be 0. Every other part of the diagonal, or every other part of the matrix must be 0, and only the diagonal part has to be a number to be a diagonal matrix. So as you get, we also can say matrix like 7, 0, 0, 0, 0, and 5, 0, and 0, 1. So this is also the same as this one. So this is also the diagonal matrix. So the diagonal has a number, but other parts, all other parts are 0. So that's the thing with the diagonal matrix. Well, when you count the identity matrix is a diagonal matrix. Then it means that it is also a square matrix. Since it is a diagonal, it is also a square matrix. And then the thing with the identity matrix is their diagonal number or the diagonal numbers are 1. So it is always 1 to be identity matrix. The diagonal numbers must be 1. So that's the thing with the identity matrix. This is also the easiest because if you guys see the matrix that has 1 in the diagonal part, it means that it is identity matrix. So now let's go to some other type of matrix. Okay, now the sevens will be the scalar matrix. Well, the scalar matrix is a diagonal matrix, but the thing with the scalar matrix is, as you guys can see, the diagonal part, they match or they're always the same. So if they are always the same, it means that it is a scalar matrix. So we can also take an example like if it is 7 0 0 0 7 0 0 0 7. This is also a scalar matrix because since the diagonal numbers match. So if the number that is found in the diagonal part, if they match or they're the same, it means that they are scalar, or it means that the matrix is scalar. So that's the thing with the scalar matrix. And also scalar matrix are also square matrix since they are diagonal matrix. So that's the thing with the scalar matrix. Now let's go to the eighth one. So this one is a low triangular matrix. And the reason that we call it a low triangular matrix is because look at the numbers over here. So if you guys see the numbers, if if there is a number in the lower part of the matrix, we call it a lower triangular matrix. So as you guys can see over here, there's a number at the lower part of the matrix at the lower spot. So that's the reason that we call it a lower triangular matrix. And also lower triangular matrix are also they are square matrix. So it must be square matrix to be a low triangular matrix. So that's the thing. And that thing is there must be a number in the lower part to be a low triangular matrix, and the upper side must be 0 all the time. The upper side must be 0 all the time. So now let's go to the next matrix. Well, the next matrix will be the upper triangular matrix. The upper triangular matrix is also a square matrix, and it is the opposite to the low triangular matrix since we got the numbers in the upper spot and the lower part would be 0. So there's a number in the upper spot and the lower part would be 0. So that's the thing with the upper triangular matrix. So the difference is when you count the lower triangular matrix, the numbers are in the lower spot. But when you count the upper triangular matrix, the numbers are in the upper spot. So that's the only difference between these two. And they both are square matrix. So this is it, and we're done with the type of matrix. And thanks for watching, and have a nice time.